what we're going to do today is we're going to use determinants. No, I'm going to add to it. We're going to use the determinant to help solve systems. Now, it may not be the easiest, most economical, if you will, way to solve a 2x2, because a lot of times you do substitution and some quick solving that way, which is pretty nice. But when you get to larger degree ones, where you're 3x3s, 4x4s, using determinants is ridiculously quick and simple. Because instead of having to use multiple forms of multiplying and adding together or subtracting together to use a lot of elimination, it's easier to just multiply and add, do some subtraction. So usually most people tend to find that determinant usage is nicer. So let's talk about what's called Cramer's rule. And what I'm going to do is I'm going to use this matrix, or this system, as our example. And Cramer's rule is always, always, always going to start out the same exact way. When you use Cramer's rule, what you're going to be looking for is you're going to be looking for the coefficients of the variables. So in this case, well, first of all, the mistake you're going to make is you're going to forget to put a negative in. Okay. But in this case here, we're going to create what's called a coefficient matrix, which means I'm just going to take the coefficients from where they are and just rewrite them out in matrix form. So the coefficients of the example I have here would just be 2, 1, 3, negative 0. That's always, always, always going to be my first step. Hey, I missed you. I haven't seen you for that's cool. Sure.
Who is it? Wait, who is it? Can you have him come?
All right.
For Katie?
You guys, do you want to say hi to Miss Wolfsco?
Who is it? Oh.
I had her dad for a college professor. He's pretty cool.
Who is that?
It's Holden, and I'm going to go beat him up.
Holden, go to class.
Go to class.
Holden, do you have a class this hour?
Yeah.
Do you ever go to it?
Are you interested in it?
Oh.
Cool. Pass your final year.
Wait, hold on. How are the little kids?
Anyway,
In the Mrs. Holt's class.
I don't know. I don't have that class. I just go for fun.
Oh, okay.
What the heck?
I'm sure those little kids.
What do you do?
Are you like passing any of your classes? Does he just?
you need to be eligible, right?
For what? Swimming?
Yeah.
I got past 5 out of 7. Yeah, I'm good.
Oh no, we lost.
Glad you
the
said the
marker.
pink one. I hate that one.
Oh good.
Really? Thanks for the marker.
Oh, he's keeping it. Oh
Come on, class. You can't spell anyway. You know we can't read this backwards.
It says
If you were smart, you could write it backwards.
Mr. Murphy. He's gonna write Mr. Murphy.
Y-O-U-R-N-A-M-E. Go to class. Go.
P-H-Y.
Oh, I get it here.
It took you that long? Seriously?
I thought you said Y-O-U-R-E, and I was like, you're an am.
Alright, so like I said, what you're going to do with the Cramer's rule, first thing you do is write out your coefficient. We're creating what's called a coefficient matrix. Find the determinant. -4 minus 3 is -7. Finding the determinants of 2x2s is ridiculously simple. Okay? So now, here's what we're going to do. We're going to take the solution column, the 1 and the -23, and when I go to solve for x, I replace the coefficients of x with the solutions because that's what I'm solving for. I do 1, -23, 1, and -2. I put back in the other column, and then I find its determinant and divide it by the -7 column.
Wait.
Stop. Do what I just said. I took the column of the solutions. I'm solving for the x. I take the solutions and I put them in where the x column is. I replicate the y column that we had originally. I find that determinant. -2 minus -23. It's 21. I divide it by -7. X is -3.
Oh, okay, that makes sense.
You just, ignore the 2x and 3x.
Well, you just replaced
I
that.
did
All I'm
negative.
doing is replacing. When I go to solve for y, I take the solution column and I replace the y column in the original matrix. And I will write 1 and -23. In the x column, I put back in the original two values, 2 and 3. What do you think I'm going to divide it by? I'm always going to divide it by the original determinant. It is a very efficient, quick way of doing things.
Wait, are those lines like?
Determinant, remember upright scheme determinant. That's it.
Isn't it negative 39? It's minus 2.
Yes, thank you.
So
Why did I get 42?
But you probably get it.
Yeah, either way.
You still win.
Wow. Anywho,
So
what I'm doing, I take the original matrix, find the determinant. When I solve for x, I take the solution matrix and I substitute in the column of x. Take the determinant, divide it by the original. Solve for y. The solution's in for y, find the determinant, divide it by the other. Done. What's up?
Okay, but after you solve for x, couldn't you just technically have...
You can, but I'm going to want you to use determinant.
But like that's just like another way to do it.
What I'm showing you guys here is that obviously in the 2x2, it's a lot easier just to do substitution and be done. This is just another way of solving systems because as you get to a more complex system, it's quicker. It's a lot quicker.
Yay.
Okay? Let me show you again. Same idea. We have the original equation, 8x plus 5y is 2, and 2x minus 4y is -10. What you want to do initially is write out the coefficient matrix and find its determinant. You get -42. Okay? It's quick. It's easy. Determinants are your friend. To solve for x, what do I put in the x column? 2 and -10. In the y column is the 5 and the 4, -4, excuse me. And then I divide it by
Oh, because
Sorry.
you're divided by the determinant, so I forgot about that. That's what we did. It's actually fine.
So you have -8 minus -50, which is 42. What's up?
For the y, do you use a different diagonal, like
Yep.
subtracting things? Could you go back to the last?
When I go to y, watch what happens when I go to y.
No, I know, but I don't know what they did.
I'm going to take this column in, put it into the y column. So I'll have 8, 2, 2, oops, and then I divide it by -42.
So we're going to do this with factories too.
You're done. Yeah. What's up? I don't know this part. What's up?
Oh, why is the 2 and -10 on the left for one side and on the right?
When I'm solving for x, it goes to the x column. When I'm solving for y, it goes to the y column. That's what moves. What's up?
How come you use the 2 and -10 instead of like the 8 and 2? Like, how come you chose?
I'm solving for x, so I'm putting the solutions in the x column.
You use that for the y too.
When I solve for the y, I put them for the y column.
Wait, which one
Well,
is the
like,
y?
how do you choose? You chose like the second equation, use those, and why did you use the first one?
What do you mean?
Like,
What I'm doing here is these numbers are always there. When you're trying to solve for x, you take these and you oops. You're going to take these in for x. That's what I did here. I found its determinant. And I divided by the original determinant.
and so you do the
And then I did the same thing for y, replace those with solutions, use those x's, find the determinant, and divide. Same process every single time. Sir?
But how do you know what side to put the numbers on?
What are you solving for? You're solving for x, you put it in the x column. You solve for y, you put it in the y
When you
column.
say the x column, you mean like if 8x.
Yep, these are all x's, these are all
It
y's.
says 5y plus 8x, so negative 4y plus 2x.
Huh?
What if it's a
Or if it was flipped, it's the same thing.
Then you just put, if you're solving for y, you replace it with the y column. It doesn't matter.
Doesn't matter if it's on
It-
both of
You just replace it with what you're putting. You just have, stop clicking, please, thank you. Whatever your column is,
like column, like x and x, y
Yeah.
and y.
which if you're solving for x, you put those in for x.
So it's a matter of left and right.
That's it. That's all it is. It's, you guys are overthinking the,
Well, you just like jumped into it. This-
oh yeah, because you should, it's a determinant, which you guys know it's simple. Just one little baby step further. Last one of a 2B time, yes it is. Last one, before I go to the 3. (2x plus 7y, negative 3. 3x, negative 8y, negative 23. Get your coefficient matrix. Find the determinant. Negative 16, minus 21, negative 37. Yeah.
So, I was gonna say this earlier, but yesterday, when I was like actually like doing it, I just thought of like the fish thing, like from third hour, because like I couldn't remember which one to like put first, so I was like, wait, he said it's like drawing a fish.
Remember chutes and ladders. Chutes and ladders. Chutes are the ladder. Or you go down a chute before you go up the ladder. So you have to go chute, then ladder.
My life is going downhill when I'm trying to get it up there. That's how I remember it.
I just remember drawing this
Then solve for x. With negative 3, negative 20 and 3 for the x column. 7 and negative 8 for the other one. So you're going to divide it by negative 37.
Seven times 23.
So that's
Do you
what,
guys get negative
161. Minus 24 is what?
I think it's
37?
137.
Negative 137 over negative 37.
It's
11, I believe. Isn't it?
No, it's a decimal.
All right, whatever.
Do we just keep it like that?
Sure, simplify. Just simplify. And then you do the same thing for y. What's up? Ah, yeah, I missed the sign. Thank you. I missed the sign.
That's like 2.
So you're 185. Now it should be better.
5.
It's 5, negative 5.
Oh my.
That's the worst thing that'll happen. You'll forget a sign. Do the y values. Solving for y, you use the original x's, which were 2 and 3. The y column becomes negative 3, negative 23. Get its determinant divided by negative 37.
It's negative.
Negative 46
Wait, so this should just remember
plus 9 all over negative 37, so you get 1. It is another means for solving systems. That's all it is. It's just another means for solving systems. it's real quick for 2x2s, but remember, 2x2s are pretty easy to crank by hand anyway. But the advantage of this is hugely for 3x3s. It's so much easier to do a 3x3. Let me show you.
It's easier.
Oh yeah, so much easier to do 3x3s.
I thought that was one here.
Oh no, I mean instead of doing it long form.
Okay.
Because you wouldn't want to try to do long form 3x3. That's a pain.
When you talk about long form, that's when you rewrite the first two columns.
Well, long form is what you have to like use elimination and substitution to get all those things out.
Get your
Now, when I'm using determinants, it's pretty quick. We're still going to find the coefficient matrix is find its determinant. Okay? So basically within this problem, you're finding 4 determinants. The original, one with the x values, y values, and z values. So your original determinant, I'll let you guys write it down here. Remember chutes and ladders. Go down first before you can go back up. Plus negative 12, so that's 10, so that's negative 2.
I had
9, 4, negative 8. So that's 5. So it's negative 2 minus 5.
Yes.
Yes. Determinant. Okay. Now when you want to go solve for the x values, what are you going to put in the x column?
Negative 2, negative 1. I just get a couple of how did you do that? Like I looked at columns.
How'd I do that? How'd I do this that fast?
Yeah, oh, why did you do that?
4. Well, 1 times negative 1 times negative 4 is 4. 2 times 1 times 3 is 6. Negative 3 times 1 times 4 is negative 12.
It's easier if you just rewrite the.
Oh, I have the wrong number here. That's why. I was like, why did I get that wrong?
Yeah, like I keep saying, this is where you really have to pay attention to detail. Just making sure all your signs and stuff are right.
I just messed it up.
Shouldn't that be okay?
Imagine this was like a professional.
Sorry, it's 12.
Why is it going to be? I got
3 times negative 1 times 4.
Okay.
I read it over to the negative 1 here. Then going upwards,
Yeah, no.
so you get 12 minus 12, which is, so x equals 0.
I'm glad this stuff isn't hard.
We'll write it down and it'll get even easier.
Well, I just watched the video.
Here's the originals. 1, 1, 3.
Oh, okay.
We're working determinants going, chutes and ladders go downward first. We have 4, -2, 1, and 3, -6, -3, 1, and 4, -12. So it's -14, I believe.
So wait, why did, on the last one?
Wait, isn't it? Oh.
And then going upward, we have 9, 4, 1, and 1, -4, -2. So that's -14 minus 21. So you get -35. So y is -35 over -7. 5. Sir?
I still don't understand like why you're putting the equal like in the middle.
Because I'm solving for y.
Are you like replacing the one you're finding?
Yeah, that's the rule. Take the solutions and put it into the column you're solving for.
Okay.
And then now where do you think we'll put it next time?
All the way to the right.
Yeah, in the z column. And then I put down the 2 original x's and y coefficients. Yes, ma'am.
Is it okay if at this point, since you know 2
I want you to write it out.
There's a question.
Because I've been asked that many times.
I'll be worried that I like did something wrong.
1, 1, and 3. 2, -1, 4. And the last one was -2, -1, and 4. And divide it by -4 minus 6 minus 8. So that is -10, -18. 6, -4, and 8. So it's -18 minus 10. So you get z is -28 divided by -7, otherwise known as.
So Sarah, 5 y 4.
Qué bueno para su clase de español.
Wait, how do you say oh my gosh in Spanish again?
Dios mío.
Huh?
Dios mío.
Adios, niños.
Adios niños, adios granddaughters.
No.
Dios mío.
No, that's a boy. That's a no. Niños is girls.
It's like kids.
Kids. Adios niños.
I thought it
Hi,
was
kids. Like every time you just frustrate. Bye, kids.
Oh, adios niños.
Dios.
Dios.
No, there's no N.
Dios.
Dios, which means gods.
Niños.
I just said there's
And I'm
no
just thinking
N.
about little transitions.
Mio.
Keep Dios here and see
My
what
God.
works for yourself.
Seriously,
How to say oh. Adios.
No, no, stop, stop. You're making me angry.
Allie cannot speak English. You should hear him.
What do you say musical? Wow.
You
can say like theater.
She'll say like cougar and she'll say bird.
I'm so confused. I think we got so lost.
Zero,
6 divided by
2, -1, -2, 4, 5, -5 is 5 is 40. 0, 1, -10, 3, 6, 48. So it's 44 minus 38.
Over 9.
Was it negative? No, sorry.
So negative
6? Yeah, so it's 6. So x is -2/3. Y will be 360. -10, 8, -2. What's that?
Where'd you
Where's the 38?
The upwards, it's 0, 1 times negative 10, 3, 2, and 8.
I forgot to put the upward.
Yeah, that's bad. Divide that all by 9. Upwards give you 0, 2, 6, 3, 18, negative 180. So negative 174.
What?
7 what?
No.
Yes, yes.
Yeah.
Yes. Hold on. You're right. I know where I went wrong. I did a lot of wrong stuff. Hold on. What is he looking at?
I think there's a sub next to it.
Hooligans. Go yard. Is that why it's so loud?
Did someone finally show up?
They're lying. What did they do for this fucking? No.
Yeah, down, down.
I already.
Oh, I missed. I did it. Wait,
Yeah.
did I?
No, I got it.
All right, it should be
Let me start over here. So this is
72.
72
Plus 60. Plus 0.
plus 0, and that's a 0,
And then plus 60.
plus 60.
Why would I
Okay.
132.
Going upwards, going up, we have 0, 2, 6,
6.
3, negative 30, negative 180.
So, wait. Negative 172.
So you have, hold on. So you have 132 minus a negative 174.
Oh, 172.
So you have 6, a 0, a 306 divided by negative 9, which is negative 34. Yeah, it's if you hear a lot of people saying negatives here and that, you can get lost in what you're writing now. Okay. And then the last one, you just replace the z column. So we start with 360, 1, 0, negative 1, negative 10, 8, negative 2. What's that?
730.
7:30.
Oh, I wrote it wrong
Every single one
here.
is 7:30 and the Sunday one is 1 o'clock.
Okay.
That's a lot.
Not fancy.
0, 16 times 0, negative 10, so we have 60. Upwards is 0, negative 24, and negative 28. Sorry, wait. 8, negative 24, negative 2, 4, negative 24, so that's another negative 24.
It's 4.3.
So it's 60 minus a negative 48, which is 108. So we have 108 divided by negative 9, which is down 11.
It's 12.
It's 12, yeah.
Yeah, I did that right.
Those are your answers?
This is 4.3.
Yeah, it's just the last bit of primary rule.
These aren't that hard, they just take forever.
And you have to like focus on it.
Like you can't be doing two.
I want you to do 40, 41, same page. So it's what, 219?
Wait.
And 48 and 50. I'll put them up here so you guys can get a picture if you want. I want you to do those 5 using Kramer's rule, please.
Oh, 40. Hey.
Oops.
Wait, 48.
Yes. We have to make choices. Good choice.
I'm gonna run out of room.
Come on.
Nah, I still got a good old
Know the bad.
Yeah, I don't know any of this stuff.
8 pages left, but 6 days left, but I need a page for each homework items.
Is this supposed to be leading up to like
So I have 8 pages left after this. That means that I have 4 days of notes and homework. So I just gotta